Hello, math lovers. In this video, I have an interesting geometry problem for you. We have been given two circles which are concentric, which means they have the same center, which is this. All right, and then we have a construction. We have been given a chord which is also a tangent to the inner circle, and we have to find the area of this region. All right, so the region between the two circles, we have to find the area of that. So how do we do this? There are two ways of solving this problem. One is a longer method where we use the Pythagoras theorem, and there is an intuitive shorter method. We'll cover both in this video. So let's begin. So let's do the longer method first, and let's do some construction. So let's draw a line from the center to the point where the tangent meets the circle. So let's say this is the point. Now we know that also let's draw one more line which is starting at the center and ends here. Now obviously this is the radius of the smaller circle and this one is the radius of the larger circle, and let's name these. Let's call this capital R and this one small r, lowercase r. And we also know that this would be a right angle triangle. So this is 90 degrees. Also, this line will bisect the chord, which means divide it into two equal parts. So if this point is A and this point is B, then AB will be 8 centimeters. All right, so this is 8 centimeters. Now we have a right angle triangle. We know the length of one side. The hypotenuse is uppercase R and the other side is lowercase r. We can apply the Pythagoras theorem, which is 8 squared is plus. So 8 squared plus r square is equal to capital R square. Now let us multiply both sides by pi. So we get pi into 8 square plus pi r square is equal to pi capital R square. Pi capital R square. Now let us take this term to the right hand side. So we'll get pi 8 square is equal to pi r square minus pi r square. And this is exactly what we had to find. So pi capital R square is the area of the bigger circle. Pi lowercase r square is the area of the smaller circle. And the difference of the two is the area of this region. And this is pi 8 square. So this was the first method of solving this problem. Now let us look at the second method of solving this problem. Now let's assume a situation where the radius of the smaller circle keeps reducing. So if you keep reducing the radius of the smaller circle, then what happens is this thing, this thing, it just keeps increasing. All right, it just keeps increasing. And it becomes at one point, it becomes the when the radius of the smaller circle approaches zero, this becomes the radius of the outer circle, and this is still 16 centimeters. All right, this is still 16 centimeters. This entire length, this is still 16 centimeter, which means the radius of the outer circle, the inner circle, is now zero. Its radius is zero, and the radius of the outer circle becomes 8 centimeter. Radius of the area of the smaller circle is zero, and the area of the outer circle is pi 8 square, which is our answer. So you don't have to go through these steps. You can simply assume the inner circle to be 0, radius 0, and then the area of the outer circle, the larger circle, is pi 8 square or pi to whatever the length of the given chord is, square of that. So I hope you liked this video. If you did, give it a thumbs up, and I'll see you in the next one. Till then, take care.